We're looking at question 25 for a Webassign chapter 20, which is the carbohydrate section. So in this question, we're looking at it's asking for you to draw to supply the structure of a disaccharide, which is composed of two D-glucose units. So using that information, let's just get the basic structure, okay? And the easiest way is let's just put it, we know it's going to be a six-membered ring, so let's put that in there. And we're going to get our oxygen in here, because the two rings will be connected, they'll have this oxygen in common. And then we have this here. Good. So there's the basic structure. In addition, this oxygen, so glucose, this is the Haworth projection here on the left. On the right, it's really not quite an official Haworth projection, because since they're hooked at the 1,1 anomeric carbons, that means that this one carbon and this one carbon for glucose are what they have in common. This glucose has to be, flipped over, so the oxygen's on the left side. Now, we can also, since we know it's a D sugar, we can also put the CH2H group in as such. Okay, that makes that easy. Now, since this is basically the ring on the left is basically the same as the one on the right. You just got to flip it over like a pancake. So this is the fifth carbon here. That'll end up being this carbon here. So when you flip this over, this group will be going behind the plane. So let's do that. Okay. Bingo. There. Okay, so we have that. Now, the other thing we need to do is, what we can do, make our life easy, is look at these the anomeric carbons. What's the stereochemistry there? And the information given in the question, let's see, it says it's hydrolyzed. So the anomeric carbons, or the glycosidic linkages, are hydrolyzed by alpha glucosidase, but not beta glucosidase. So, translation, they're only alpha, okay, at the anomeric carbons. So if we look at this glycosidic linkage here, we know it has to be alpha. That means it has to be opposite of the highest numbered stereocenter. Okay, so compared to the highest numbered stereocenter of this sugar, this has to be going, that's going up, this has to go down. Likewise, this here, this carbon with the highest numbered stereocenter, that's going down, so this has to be going up. Okay, so, to just be clear, this is a glycosidic linkage on this side, and that's a glycosidic linkage. Awesome. Okay, now all that's remaining is to assign the stereochemistry for the remaining OH groups. So, let's get them in there. Let's put them in. Okay, so, here we go, there. That's weird. Why did it do it? Let's fix that. Control. It's supposed to be just up there. So now I'll leave that up to you. So remember, that's the 2, 3, and 4 carbon. So, is it coming out at you, or is it going behind? Okay, so, and once you assign these here, actually, then it should be really easy to assign these here, because it's just this molecule flipped over. But take note, this is starting here. That's the anomeric, so that's for glucose. That'd be the 1, 2, 3, and 4. So this 4 carbon here would be equating to this carbon over here. Because remember, the anomeric carbon for this side starts here. 1, 2, 3, 4. So, for example, if you thought this was coming out at you, if that was the correct assignment, then this one should be going behind the plane. Okay. Well, okay. That you'll have to decide. Okay. Okay. So, hope you find this helpful.